record a dance. A video does a nice job, but even still, the viewer sees only one frame at a time. And although a dance is composed of a sequence of steps, the whole is more than the sum of its parts. For a dance is about the pathway. How does one get from here to there? A body has many parts and a dance has many bodies, and the information contained in each moment is enormous. So let's just focus on the position of those bodies. With the dancers confined to a stage by gravity, we can represent their configuration with 3 points in a two-dimensional plane. Consider another space representing all possible configurations. Every point in this other space corresponds to some position of the dancers on stage. And as the dancers move, they trace out a path in the space of configurations. One way to access this space is to study the loops. But what does a loop in this space represent? It is a movement sequence where the dancers return to their starting positions. There are two types of such loops. Those where the dancers return exactly to their spots, and those where they return but rearranged. For our purposes, let's not care about who is in which spot. So a loop is a dance which brings everyone back to some starting position. Imagining such a loop all at once still feels like an impossible task. For how can we keep track of the exact way 3 bodies move around each other? The answer comes by introducing a third dimension representing time. In this 3-dimensional space, each dancer is represented by a vertical rope, and time flows from the top of the rope to the bottom. The top ends of the ropes are fixed in the dancer's starting positions at time 0, and the other ends are tied to the dancers, who are in a current configuration. With this new perspective, we witness the dance in a new way. A dance can be recorded as a braid of the dancers through time. We can now grasp at a more fundamental notion for when 2 dances are the same. 2 dances are the same if they produce the same braid. You might say dances with the same braid are topologically equivalent. Mathematicians will often study a complicated space by looking at its loops. It is called the fundamental group of the space. Using mathematical language, we have learned that the fundamental group of the configuration space on 3 points is exactly the braid group on 3 strands. Configuration spaces appear in many fields of math, including topology, dynamics, and algebraic geometry. For us, we are left with a beautiful correlation between dances and braids.